Hello, Pawan. Can you hear me?
Hello, yes, I can hear you. Who is this?
Hello.
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 Hello, can you hear me?
Just give me a second.
Am I audible? Am I audible?
Audio is not coming.
I can hear you loud and clear. Can you
Can you go to the left hand side corner and just check? In display, can you check the audio?
there's 1 second.
Speaker is not connected, right? See? Video
There is a
also
long
there.
delay.
Open video. Left hand side corner. And you check in that like the camera. There is
Audio.
option was enabled.
Audio, it's not enabled.
I can hear you fine. You can't hear me, or sir, can you hear me? Hold up your thumb if you can hear me, sir. Can you hear me? Sir, can you hear me?
Video is working. Audio is not coming.
Can you hear me? No? Yes? No?
Which one?
Can you hear me?
One sec.
Is it ready?
You see, you can sit down, sir. Audio is not coming.
Audio is not there, eh?
Audio is not coming.
Means from here it's not going out or not coming in?
Inside it's not coming.
Both sides not working.
One side, sir.
Okay.
Sir, I can hear you loud and clear.
Okay, now it's in blue color, right? Okay, then you go to that audio display. It is showing in display or Zoom display. So go and check whether the audio is connected to this one or this one.
Audio ಬರ್ತಾ ಇಲ್ಲ.
Some reason the audio is not coming.
I'll call you back. Wait a minute. I'll check. ಎಲ್ಲ ಬರ್ತಿದೆ. ವಿಡಿಯೋ ಕಟ್ ಮಾಡಿ. ಆನ್ ಮಾಡ್ತೀನಿ. ಸೆಕ್ಷನ್ ಮೇಲೆ ಹಾಕ್ಬಿಡ್ಲಾ?
Hello.
Gururaj, I can hear you loud and clear.
Hello.
ಅಲ್ಲಿ ಬರ್ತೀರಾ? ಆ ಕಡೆ ಎಲ್ಲ ಬರ್ತಿಲ್ಲ. ಮಾತಾಡ್ತಿರೋದು.
Microphone output ಬರ್ತಾ ಇಲ್ವಾ?
It's audible to me, Gururaj. I can hear you very well. And it is coming on YouTube also, the audio, your audio.
Yeah. Now we can hear you.
I can hear you guys also very well, Gururaj.
You can start now.
Are you able to hear me now,
Loud and clear, sir.
Pavan?
Loud and clear. There's
Yeah.
a delay, there's a time lag,
Yeah,
but
right,
otherwise
right.
loud and clear.
No, I think is last time when I came, no, somebody was there. Maybe not this time. Some other slot. So I was, came a little early inside, and good luck for me, Police fellows were catching everybody. The only time I cut the road and the fellow was waiting on the other side. Luckily, I
Oh,
went
no.
off to IASC. Anyway, no
Otherwise you
problem,
would.
sir. Is it now online to all the public wherever they are there? Yeah. So nobody else has joined as yet. Right. No, students.
No students joined, sir.
None of the students have joined. It
No.
will come here.
Yes, sir.
NPTEL is there, Pavan, and NPTEL office. NPTEL office is there. Yours. You're able to see.
Yes, sir.
Okay.
Sorry.
No, sir. You can.
Oh, participants, I am Chalapati Rao from Indian Institute of Science, and that is Pavar Sridharan, who was my student, and he was in Center for Product Design and also in our place. Then we have been working on this thermal for quite a long time. Meaning, I had a background this thing, and uh, the thermal at the chip level has taken a lot of interest. Meaning, in fact, there's a huge laboratory here which shows how to find out what is the core temperature of a chip which is inside using a spectrometer or a spectrophotometer. Meaning, they concentrate it on that and then give a thing and find out what is the temperature by checking this thing. Very briefly, as the temperature is going up, they're able to record it. However, at the system level, it is still the what you call run by professional organizations, people who make equipment and then people who make the racks and all that. So those things are not yet what you call it's formalized, but still modeling an enclosure from a what you call using fluid mechanics is still very complicated. So if somebody does have a knowledge about how to start and where to start, I'm what you call very confident that you can do better. So if you see huge the things, like if you see, even if you see our mobile phone, you'll notice that it's a tremendous amount of heat is being generated, but somehow they've ensured that it is taken away across the what they call the enclosure. Now we have come to a slightly larger system, like let us say a PC enclosure. You'll notice that inside the PC enclosure, we have the what you call various heat sources. One of them is the main chip. Loosely, people call it a Pentium chip, and hence lot of cooling devices are available. So in fact, like we have Xerox, a Pentium cooler is a generic name for a thing which 1 minute, I'm a 1 minute. Right. Right. Tell me, sir. So if you take, for example, a PC enclosure, you'll notice that one of the main sources of heat is the main chip. So we have a generic, what is called a Pentium cooler. Actually, more than anything, we have the ball grid array, which is, maybe around, I'll use, loosely the word about square inch, 1 inch by inch, and then the amount of heat flux there is very, very high. Hence, there are multi-stage coolers on top of it. The simplest thing is probably a circular heat sink, which you have a fan also, and then the whole thing is there. You would have seen those things. Now, after the heat it is generally not taken directly out of the enclosure. Got it? No, it's not directly taken out of the enclosure. It is just distributed inside the enclosure. Only when very high professional things and gaming consoles, you'll see that sometimes they're even liquid cooled. Meaning you have tubes and you have in probably a heat pipe arrangement, and then all the heat is taken away and then it is distributed outside on one of the sides or on the back of the enclosure. This is about the system level. I mean, what you call sub. Now, when we come to a larger thing, like a big communication rack, you'll notice that lot of these things are all mounted there. So the extreme example is probably Bitcoin mining equipment. Bitcoin minings are, each of them has 32 to 64 core things, and then huge amounts of racks are there. And then people say we can heat up the rooms with it. It can be used for cooling the lab itself. That much of heat is generated. So somebody said Bitcoins, this thing, the mining equipment is more used for warming the ambient than anything else. Now, the other extreme, there are high, tremendous analytical solutions called CFD. You understand, no? Computational fluid dynamics, where this heat generation and this thing is treated as a fluid problem, and then it is treated as in fact, mass and temperature problem, and analytical solutions are available. Sadly, they're all on standardized cross sections, meaning if you have a channel of a given length, of a given depth, and then given what they call heat flux, what should be the what they call the amount of this thing it is required. So in there, I have explained it in my this thing. You see that there is a system curve. System curve shows as you keep on increasing the what they call flow, how the pressure keeps increasing. Other side, you have the fans. All fans, we are all familiar. Like, you have a fan, and then there is a what you call in the catalog. They write, no, this fan can give so many what you call CFM, okay, cubic feet per minute or something, act. And then they'll give a pressure also. But magic is that pressure is computed at stall time, or at least the peak pressure. And then the CFM is given when it is free flow. So you can't multiply both of them. So there is a curve like this, and it is not even a what do you call? It's not a simple, A into B, that is flow rate into pressure also. So somewhere somebody has to accurately calculate or estimate, what is the flow rate, and hence do whatever is required to increase the this thing. So I will stop here. Any of you who can have some questions, please, make the questions. My student, Dr. Pavan here, will now take the questions. Okay. Yes, Pavan. No, this thing, no? I'm blessed with hearing aids.
Yeah, understood. So one more thing I'd like to add, that Bitcoin mining is a bit of fallen out of fashion,
Yes.
in that now no longer are they diverting GPUs to
Oh,
Bitcoin mining.
okay.
Now all GPUs are being diverted to,
Oh,
you guessed it, yes, training AI models, right?
okay, good.
So now compute, what in the industry is called compute, which is computational capacity available on the cloud, is now being rerouted to training deep learning models for AI, large language models.
Okay.
As a result of which compute capacity has become far more scarce across the board industrially, and people will very soon understand what is the cost of outsourcing your thought processes in terms of thermal addition to the environment.
Yes.
Yeah, so that's what's going to be a very important thermal topic in the coming decades or maybe forever.
Yes, sir. I'm waiting for one of the students to what do you
There was
call
a
it?
sir, there
Join
was
the
a
discussion.
Prem Chandra. There was a Prem Chandra who logged in
Yeah.
and logged off.
Where is Prem
Um,
Chandra? Yes,
no
suddenly.
idea. Maybe if you're on YouTube, you can log back in and introduce yourself. Even if you don't have a question, you can feel free to introduce yourself and discuss your objectives, goals, your thoughts, any doubts you have, what you can do. We are available till 11:30 to talk to you. So looking forward to hearing from all of you. So on the forum, on the forum, we have an introduction to someone has introduced himself. One Venkat Sairam. He says, myself Venkat, I am from Bangalore, having 7 years of industrial experience. Welcome, Venkat, and we hope you're finding the course useful. Right. Anyone else, if you want to log in, say hello, tell us your thoughts, we welcome it.
So, hello me. See, yesterday I had occasion to go and stand near a, what do you call, the new fast chargers for electric vehicles, something called e-pump, some thing they have set up one near my house. That person was good enough to open it and show it to me. So when you open that huge rack and open it, at the bottom, there is a monstrous, what do you call,
Heat sink.
a compressor, which is generally seen only in 5 to 8
And air
what do you
conditioners.
call ton refrigerators. Huge
Mm.
thing, monstrous it is. I
Mm.
mean 8 ton AC
Was it
and
a
then the refrigerator
hermetic compressor? Is it, sir?
compressor.
Hermetic compressor.
Hermetic. It is this
Ah,
big. I mean this
right,
wide and this high.
right.
I have the pictures. I'll give it to Pavan to see if he can post it. Then
Sure.
this whole thing, it chills water because there's a for some technical reason, no, they have provided a little what they call water reservoir, more as this thing, and then it does that, and then this whole water thing, no, cools. There is a big connector. When you push the connector from the EV into the that system, water is sucked in that, and then it is directly used for cooling the battery. And that is where the what do you call, I will say little tricky affair happens,
Yeah.
because huge amount of what do you call 300 to 500 amps power source is there, and the voltage of that things, some are 72 volts, some are 142-volt batteries. And at 72 volts, if you want to charge the battery and then pump 300 amps, it can only stay pumped on for maybe a second or two, and then the temperature rises. So between each groups of cells on each cell, a battery management system is there which communicates with the device which is sending all the what do you call power from there. So the source, there is a power which can be controlled, and then at the source there is a this what do you call refrigerant thing, and then there they have maintained by default, no, the whole system is maintained at 10 degrees centigrade. But as soon as the pumping and the discharge starts, then there is I'm sorry, they cool it cooler and cooler and make sure that it doesn't form any, it doesn't become too thick to pump or anything. Now on the vehicle side, in the battery, they have huge channels which are, take all the whatever that coolant thing is. I expect right now, no, it is probably a little similar to the
Car,
our what do you
car
call
radiator,
car. This thing is
car
there,
radiator. That's right.
a little similar to that liquid inside.
Ethylene glycol.
Yeah, so you have propylene glycol plus this thing and then some coloring agent,
Color.
no?
Yeah.
This thing is, pumped at a fast rate. So rate is controlled, temperature is controlled about the cooling. Similarly, from the electrical point of view, no, current is the issue. and temperature is monitored all the time, and then naturally you have to consider the voltage. So you have voltage, current, and then you have temperature, then you have water, the flow rate, and then the temperature of that also. All this goes to the battery. Now, this is very similar to what all the EV cells, especially the famous Tesla
Fast
floor battery,
supercharger.
is there
Supercharger.
like that. So it is possible. And why I'm saying this, the amount of that flux that is, used for any pumping and all that, is getting higher and higher. But they're able to manage it. At the moment, there's no problem. And to be on the safe side, no, the rate of temperature rise is critical. Saying within that whatever specified time, no, maybe within a maybe 100 milliseconds or 50 milliseconds, if the temperature rises for something, everything is shut off for safety reason, and it renews immediately. I mean, releases. So this is the level of this thing, and this is where why I am saying you all this say is it's very specific to the particular situation. We have the book, that Steinberg book is there, and then many YouTube videos from IITs and ISC, NPTEL videos are there, which will give you how to deal with heat and mass transfer in known configurations, meaning if you have a rectangular channel and if you have micro channels, how this thing is there, and then you have phase change also. Do you allow things to boil inside, or you don't allow phase change at all? And then added to that, no, this is one extreme. Other extreme, the very small things, like for example, our what do you call this smart watch, and then in my case, no, I have a hearing aid. How to use the minimum amount of power required to run the device. So both are, how make it very, very small and how to make it very, very high. So most of these, in the canal hearing aids have a very tiny battery. It's a wonder, as to how it actually stays such a long time. So at the other end, no, we have this high power, this thing. Extreme hyper is probably what you see in what you call aircraft, and then during launch of spacecraft. Once it gets into the ionosphere, from there onward, the ambient temperature is very low. It is minus 40 to minus 100 degrees centigrade. So it is quite safe. But just during the launch, everything is, there is no factor of safety there. You can't talk about factor of safety of 10. You can't talk about factor of safety of 1.1, which is used for race cars. Here, factor of safety is just one. Everything has to be calculated and it has to work best. So this thermal issue, no, is a real-time issue. So, Sir Pavan, you have worked on this, what you call body suits for cooling during our COVID times, Can you update us what has happened since then?
No. So now that is being revisited. And that isn't, of course, that's due to the larger air pollution issues that are going, the climate issues that are going on.
Okay.
And also not to mention the urban heat island effects due to excessive concretization and deforestation of the surrounding mangrove forests.
Oh.
So yeah, but of course our requirements are not as extreme as, say, dealing with the thermal runaway of lithium batteries, which is a huge issue. And of course, now that you brought that up, sir, thermal management for electric vehicle charging is going to be the next frontier, the next differentiator for consumers, especially in the commercial vehicle space. Naturally, this is going to spill over into the consumer non-commercial consumer passenger vehicle space as well. But right now, the game is being fought on the fast charging, where there are certain companies that are claiming that your entire electric three-wheeler can be recharged in a matter of 15 minutes, right?
Okay.
Which has tremendous consequences, economic consequences for fleet owners, right? So that is where we are seeing a tremendous push. And of course, I would like to believe that they are playing with fire, but as you said, so far, touch wood, nothing has untoward has happened, and they seem to be managing this scenario quite well. So the question that I had regarding this fast charging is that did you see the condenser for this hermetic compressor? Where was the accompanying condenser? So just for the any people who are watching this, in the refrigerators, you'll generally have a condenser at the back. You might have seen on the older fridges, you would have a line of black piping going behind the fridge. So, sir, did you see any what was the condenser for this hermetically sealed system for the fast charger?
Shall I add?
Yes, please.
See, what has happened is not long ago, means around maybe 30, 40 years now, most refrigerators had that compressor mounted at the bottom. And then after they, that what they call working gas freon is, once it is compressed, it becomes hot. So it was passed on to the, at the back, it was called the condenser. You understand, no? Outside, external condenser, that hot, which is in the liquid form, will immediately, start losing heat to the ambient. And after that, it is taken inside. And then we had a evaporator inside on top of the thing inside the cavity. At the evaporator, the gas is, allowed to expand and it makes the cooling. And then again, it is taken back. Now I'll give you a puzzle and then the answer. Now the latest, they have changed the whole thing. All the new, what do you call, the so-called frost-free refrigerators, you don't find the condenser anymore at the back. Have you noticed?
Yes, yes, of
There'll
course.
never be a condenser at the back. In fact, all those coils, are all welded to the inside of the left and right side of the enclosure. You understand, no? You have the big, what do you call, LG box, left and right side. Inside that is, the things are welded here. So you don't have any condenser at the back. Now my big thing is, I'll stop here. So what happened to that? How does it lose heat at all? I'll tell you the solution in the end. Now the other end is, you can take so-called window AC. Not long ago, there used to be a big box called the window AC, and in the AC you can see, you can see everything, and then it is stuck through the what do you call hole in the wall, and then inside the what do you call room, there is taken pass through the evaporator, and then it's sent back, and then on the back of it, you can see the condenser at the back, and then air is what do you call sent out. Now, hey Pavan, you've gone offline.
No, sir, I'm just putting off my video because my bandwidth is getting constrained.
So at
No,
the
no, I
back,
can hear
at
you.
the back, it is there. Now suddenly, two things have changed. One of the first thing you'll notice is all the AC units built into houses are no longer window. You have an evaporator, which is with its own fan and all, it is mounted inside the house, which is called the indoor unit. And then you have the condenser, which is outside, which is called the outdoor unit. So all the noise making the things around and all are at the back like that. While what was together has been split and added. In the case of refrigerators, suddenly the reverse seems to have happened. Earlier, everything was nicely split. Now everything has been put together in one box. That seems to be the paradoxical situation. The paradoxical situation is, if you were to mount the window air conditioners, you have to make a big hole in the wall, or most windows were made, all the houses built around the 60s. You'll see at the bottom, there will be a part of the window, you can open the thing and then keep the window air conditioner inside. And window air conditioners are all mounted at just around 3 feet or 4 feet from the bottom, what they call ground surface. And it worked well. But right now, what they have found out is, that is okay if you have a window to start with, and then where all is complicated. For example, I am sitting in a cubicle. You can see one this thing, that indoor unit which is on top, and there are no windows at all to this, because windows are very, very distracting. The only windows are meant for the video crew, which there are about 6 of them. I mean, 3 of them here and 4 or 5 more elsewhere they are doing it. So putting things in a window has become very impractical. Hence, the units come pre-charged. So the outdoor unit, they already have, enough freon, and then indoor unit also enough freon is there. And then after that, I will use the word refrigerant. They just join the various pipes, open one valve, and it starts working. There no more, nobody needs to charge any gas or anything. Now coming back to the refrigerators, what they have found out is, if you take the thin, what you call capillary, not capillary actually, it's a thin tube, and keep it at the back, not much of area is available for it to lose the heat. And there's another problem inside the refrigerator. So what they've been doing is they take these coils, weld it into the sides of the refrigerator. Now it has two things. First of all, whole side of the refrigerator is available for transferring the heat to the ambient, both sides. And next time you go near any shop or anything, no, a small sticker will be there saying the sides will become hot. That is a normal operation. And don't be scared. Nothing is, about to do the thing. Sides will be hot. Now the total area available for transferring to ambient is very, very high. Then there's an incidental advantage also. The advantage is because the thing is slightly warmer, no condensation takes place on the insulation. All this insulation is formed in polyurethane, so condensation doesn't take place. And overall, no, the refrigerator and the whole system, including the cabinet, lasts a very, very, very long time because no rust or anything is there. Only rust that can come is at the bottom of the door, because you open the door and often there are liquids inside, no, they get the thing. So we have done two things. We have increased the area to transfer the what do you call heat to the ambient. Another is we have managed to pre-warm the things so that condensation doesn't take place. And now comes the important thing. When we say frost-free, the actual thing where the evaporator is mounted somewhere, and cold air is blown inside the refrigerator wherever you want. It comes inside the thing, and some of the refrigerators also have door cooling. And then these two-door things, they can have left, I mean, one side, the what do you call -7 degrees deep freezer is there, and the other side we can have plus 10 to 12 degrees regular refrigerator. And added to that, several compartments are there. One compartment for it's called a vegetable freshener. There's even one corner, there's a curd maker also. They mix all this and make sure the curds are set at a given temperature. So all this is by clever management of heat and done by electronics. You have tremendous amount of sensors everywhere. Tremendous amount of sensors. And the sensors are able to communicate. And overall, no, for a reasonable price, I do not know, refrigerator, huge refrigerator, probably you can get for 25,000 rupees, which was not possible earlier. Same thing is now happening in the case of, as Pavan has pointed out, now EV cooling. I have some, pictures from the deep pump system. I will share it with Pavan, who will now put it on the forum if somebody is interested.
No, if you want, sir, what we can do is you can just share it with me now, and I'll
Yeah.
share the screen and I'll show it to, and we can walk over it. So
No,
you can do that.
see, I took it on what do you call, on a mobile, which I'm not carrying. I mean, carrying.
Acha.
This
Okay.
mobile
No, if you're
doesn't
so send
have,
it to me on WhatsApp. Send it to me on WhatsApp, sir.
Yeah.
I'll put it on the screen.
Yeah, not now, right now, no. That mobile
Wait.
is not with me.
Okay, sir. Sure. We'll
Okay.
send it on the
I will
forum.
share you nothing. It has only 2-3 things to do. One is, one part shows the what do you call, hermetical compressor, because that's the outside one, and the temperature of the water liquid. And then another point shows the amount of current that things. And there's a huge connector. Parts of the connector thing also, how it is connected. That is also very simple. But if you go to their system, it is called e-pump. On their portal itself. Now all this is explained clearly. E-PUMP pump, half an hour charging. And that is where we come to the next thing, saying this thermal management is, is getting more and more, what do you call, more and more analytical, more and more, we have to model things, and we have to make sure under many conditions things work properly. So I hope some of you students or professionals, will get a chance to work in these things. Yes, Pavan, can you add something?
No, sir. There's nothing. I mean, what I would add now is that with the proliferation of
Yeah,
sensors,
yeah,
sensors becoming low cost, there are platforms which integrate
yeah,
sensors for
yeah,
multiple inputs.
yeah,
So what is, and of course, there is the computational performance to handle, very large data streams from multiple sensors, and output data, output signals to transducers and motors and other such equipments, where now the new frontier for thermal management, as with any other engineering field, is going to be and is currently the integration of computation with control. Right.
yeah,
So you're going to be seeing extremely complex control systems, possibly AI operated, where where the models of deep learning models will be trained for various kinds of scenarios and edge cases, and the outcome of this will be extremely efficient delivery, and maximize the resource availability, if I may. For example, one of the big applications which is already coming is solar and other renewable power, right? For in both wind generation, in terms of what is available in windmills, in your wind turbines, as well as PV solar farms, as well as solar thermal power plants. You're aware, sir, the solar thermal power plants which have reflectors heating a secondary medium like molten salt, which then go to evaporate water, which then go into steam turbines to generate power in a more conventional way. So the what we are seeing now is the application of control computational based control systems and data handling, data processing in a huge way, where you're seeing very new efficiencies because of exigent circumstances, of course. For example, the climate crisis, and in terms of availability of power, the non-use of fossil fuels for power generation. So you're going to be seeing a lot of application for the thermal, and of course, we are going to be seeing a democratization in terms of thermal handling. For example, what I mean to say, sir, is that earlier thermal and application of thermal management used to be the um, only in the hands of your semiconductor manufacturers, for example, your computer manufacturers who are making chips. And so, am I audible,
yeah,
sir?
yeah. You're audible.
Right. Your camera is blinking.
Pavan, Pavan, can you
Yes, sir.
hold them for just 2 minutes? My mobile is outside. I'll get the pictures and send it
Of
to
course,
you. Huh?
absolutely,
Just two
absolutely. Yes,
minutes.
yes.
You hold
No
the.
problem, sir. Take your time. I'll just complete
Okay.
my thought in the meanwhile.
Yeah. Yeah.
Yes. So what we are seeing now is this sort of scenario, especially if you look at the EV market, like what sir is talking about. Um, a huge number of people now need to understand thermal and and the application of thermal control for hardware, right? Whereas the last 10 years ago, India's technology revolution was primarily software, where there wasn't too much of thermal management that needed to be practically applied by newcomers. The earlier people who, besides chip manufacturers, the earlier people who were actively doing thermal applications were, for example, server farms. Basically people like Amazon, and maybe big players like Reliance and Geo, where they have these huge server farms and they have to do this centralized thermal management. Right now, you're seeing teams of small teams of engineers who are actively applying thermal management principles for their everyday products. Examples being like Aether, um, examples being like Log9 materials, right? Where primarily they actively thermal matters very much in their product, right? So now we have a guys, hold on. Sorry, folks. We are getting a message, an incoming message. Dolly Thakur. Hi, Dolly Thakur. Thank you for coming. And she's saying, enhancing knowledge I'm learning through the course, useful for practical design. Could you please guide about thermal pad for SOC design? Right. I think what we'll do is I'll let Professor NBCR come in and sort of take this question. If there are any other questions, please put them into the chat window, please. And I will check on the forum as well. Professor, sir, have you come back? Have you finished? Are you back?
No, no, still
Not yet?
not
Yeah,
yet.
we'll,
We're waiting
we'll
for
just
it.
wait for. Let's just
I
wait.
actually added one more question from YouTube. Can you check that in
I'm checking, Gururaj. 1 second.
chat box? It is there.
Hmm, hmm, hmm. This one only, right, Gururaj? Dolly Thakur.
Yes, yes.
Right. Right. So basically, from what we know, right, the thermal pad is basically a pad of thermal conductive material which are put onto your PCBs, right, so that they can transfer heat from one part to another. Or one sec, I think sir has sent those messages. 1 second.
Hello, Pavan.
Sir.
Okay.
Welcome back, sir. So there's a question. There's a question here from a candidate. You can see on the chat window.
Yeah. Okay. Guide about thermal pad for SOC design. I'm Dolly, and for enhancing my knowledge, I'm learning through your course. Very useful. Yes. Something called SIL pad is available. SIL, silicon pad. Okay. Actually, it is silicone pad. Loosely people call SIL pad. And SIL pad is a trade name. It is made of silicone. And it is in a grayish thing, and as it comes from the factory, you have to peel it, stick it to whichever thing is available, and that pad itself cannot, what you call, directly transfer any heat or anything. It should be added to a heat spreader. Heat spreader at the simplest level could be just a, what do you call, heat sink like device, or it can be again a phase change device, meaning there is a small gap, and that gap is filled with working fluid and evacuated, so that when you attach it, the sill pad is used as a thermal paste like thing, and it is attached to that box, and in the box, immediately phase change takes place, and it condenses directly on top. The amount of gap is probably just a few 1 or 2 millimeters. With that, high flux transfer is possible. There's no other simple way. Any other way involves having a big, what do you call, a thing with pipes and so on, and you require probably to have a water cooling device or anything like that. So most systems on chip, either have directly mounted. Time is over. Huh? Yeah, 5 minutes. Next is also mine only. So what happens is, some of them, no, there's a small box-like thing, a blue-colored thing, usually with the water inlet and water outlet. So this system on chip thing, no, this thing is directly mounted on top of it. Here comes the very important thing, because if the chip is going to be heated, no, somehow you have to make sure that this is directly contacting the ball grid array, BGA.
Hmm.
There is no other simple way of doing it. This is all I can do it. Now you go and check on what you call phase change material cooling for system on chip. Information is available on the internet, and most of them are what you call, the companies have a patent on the way they have achieved it, including the working fluid, including the total area available, including inside the chamber itself. No, there are some grooves called micro grooves. How these micro grooves are made such that but the phase change occurs very quickly. One side it should boil immediately, then the latent heat is there. Other side you should condense immediately, so that latent heat is charged, and preferably without any active device. If you want active, there is a small, heat, what do you call, thing like this, which you take it out and connect it to a bigger thing. So I think at the moment, no, this is all I can charge.
Sir, I've shared a link, Dolly. This is a very beautiful article on sill pads and the thermal thing for SOC system on chip design. Now, if you have any specific, like your question is very broad, so if you have any specific thing that you are unable to understand, please do send a question on the forum, on the discussion forum, and we will address that very specific issue. Right? We will try to clear up what difficulty you're having in understanding that. Right? So yes, broadly the game is heating up, right? The game of trying to extract as much from computation resources as possible. You can see, so it's very important as students to also be in touch with developments that are taking place today. So there's a huge Nvidia has become one of the largest evaluated companies in the world because their GPUs, their graphic processing units, are the only chips that can handle AI, large language model, deep learning training, model training, right? So, okay. So she's given us one more question.
Yeah.
Probably fiber optics. So can you read the question? Would you like me to read out? I mean, it's not.
No, I need to, because we have not, what do you call, I have not ever touched on this optonics. And now if you give me time, I will see. In principle, now, when optonics came about, the optical the design is only about that what do you call, monomode cable, which is going there. In one side you have a transmitter and receiver, another side you have a transmitter and receiver. But inside the electronics of converting it into that laser, whichever it is uses it is like conventional thing only. And usually that manufacturers ensure that that by definition none of them gets hot. You understand, no? Now, when you go around and you see on the walk everywhere you see half open fiber, boxes hanging everywhere like that, because there's no way of repairing it. Once that fiber thing breaks, nobody
Yes,
can do
nothing can be
anything
done.
about it. So if you're talking about optical fiber communication, it's a different thing. However, when you're talking about things like what do you call large what do you call meter wave antennas and all that, no, they are huge devices, and added to that there is a reflector which will focus all this energy there. By definition, just like you have your what you call DTH, direct to home, you have a reflector and you have a device in the thing. There is usually, in our case, no, there is a low noise amplifier, LNA. That LNA the very conventional way of cooling it, first of all, try to use the ambient thing. Second thing is at that point, no, occasionally they use the Peltier thermoelectric modules, TEM modules. You understand, no? The actual cooling thing is there and power, no, is available for us. So the efficiency is very poor, maybe 3% or 5%. Still, the critical thing is how to keep the active device low. It can be best handled by thermoelectric thing. Anything else, no, it's like conventional only. So I need to check on this. Is optical design. The optical part of it is, that is somebody else's thing. But the active electronics continues to be our own, whatever we do things only. Now that this thing we have one Professor Srinivas of our EC department. I'll see if he's there and I'll get back to you and I'll give you a pointer on. He is also in NPTEL in his things and all that. Okay, so my this session now is almost coming to an end. So anyway, thank you for being here. The three questions, one is how system on chip is held. Another is how the what they call electronic cooling is done. I mean, thermal management is done. This I will, try to freshen my knowledge and then pass it on to you. So what do you say, Pavan?
Yeah. So I think my take on this is that we have largely touched upon the thermal management of systems where there are inefficiencies which are then manifested as heat, right? So where thermal management is critical to the performance of the system, where if there's no thermal management, you will have a systemic breakdown, as you will see in the if you see in the course as we go along, you'll see how thermal mismanagement has a grave impact on performance, right? And the entire breakdown of the engineering system as such, right? But I think when we deal with optronics, we don't see the level due to the laser and the reflectivity of the material that we are seeing. We don't see these inefficiency and manifestation as heat, right? So while it has its own pros and cons, especially cons like sir said, if there is a single rupture, the entire system is useless, right? So there we have a different set of problems where thermal is not one of them, but certainly thermal is an issue in all engineering systems. And we have sort of, because of the scope of this course and the level of the general level of the student that we encounter, we have chosen the most important aspects and the systems for which we want to cover. Now, similarly to optronics, there are many other engineering systems where thermal management is extremely important. Yeah, so I'll wrap up in a minute, right? And we've only dealt with the most important. Okay, Nolly. So now sir has many decades of experience with engineering systems, particularly circuit-based electronics and electrical-based engineering systems. If you have any very specific questions which you're not able to understand regarding the topic, including optronics, please feel free to send a query on the announcement forum and we will solve it and we will sort of explain it to you. Okay. So keep your questions very specific. Right? Thank you. I think we'll wrap up now. Thank you, sir, Professor NVC. Thank you so much for sharing your wisdom with the interested students. And thank you, students, for taking so much interest in this very important topic. When we started this course in 2017, this topic wasn't of as much interest as it is today. So congratulations, sir, on choosing a topic which today is far more relevance in terms of computation and especially EV cooling. Right, thank you, sir. Over to you. Any closing words?
Sir, I think it will get terminated automatically because my integration and prototype building is about to start in another 1 minute.
Right, sir. So any closing comments in a minute?
So our Professor Singh will be joining me, I think, from another lab somewhere. Okay. So thank you, Pavan.
Thank you, sir. Have a great day.
Tell these
Thank you,
people
everyone.
to what you call switch off. ಇದು ಆಫ್ ಮಾಡ್ಬಿಡಿಯಪ್ಪ. ಆಮೇಲೆ ಇದು ಆನ್ ಮಾಡ್ಬಿಟ್ಟು ಸಿಂಕ್ ಬರ್ತಾರೆ ಬೇರೆ ಲ್ಯಾಬ್ ಇಂದ. Okay.
Sir, will end it.
Yeah. You terminate this. So thank you.
Thank you, everyone.
Yeah. You sit here. See that Singh is online. I just put it on.